Good morning, Professor.
Good morning.
I have a quick question.
Okay.
Well, two quick questions actually.
Okay.
So, remember how I emailed you about my play pause? It wasn't working.
A lot of people send me like a different kind of preposit issue. Remind me?
I was just gonna say if you remember how you sent me the part 1 through 5 or something through email. Are the rest of the parts on the same YouTube channel?
Okay, so there are preposits. Let me see. So I gave you YouTube
Yeah,
links, but I found a way that you can go directly from Canvas.
yeah, and then you sent an email about that. I think it was
Right.
yesterday.
Yeah, so that's the latest version that I
Okay.
still want you to go to the play posit, but now you can go directly from Canvas.
Yeah, I
Um,
really don't know what's wrong with my play pause.
I don't think it's just you. But so then, do you have there are some people says that are in the middle, it gets hanged, or even though they take those questionnaire and all the work that you do disappear or something.
Yeah,
So.
for me, it's something's being blocked. I go to the Play Posit website and
Mm,
I click our class,
mm.
but then it's just a blank screen.
Oh no.
I'm still in the web browser and everything, but it's a blank screen.
Huh.
Yeah,
So
so
how about even you do the direct link from Canvas? Have you
I
had
haven't
it?
tried that yet. No.
Good, good. Let's see. I hope that works. And
Here, let me try that right now, actually.
okay, okay.
Where would I find it? Assignments?
Yeah, it's in assignments. So
Oh,
another,
yep.
yeah, okay. I hope it works. You can
Let's
view.
see. Yeah, it works.
Oh, nice.
Perfect.
Yeah, good. So another issue that people might be wondering is that since I had to, in order to give you the direct link from, what was it, Canvas, um, if you, I had to use assignment. And even though you watch the video, it's not, it's some people are having an issue that's not being completed. It looks like your grade goes lower or something. And so I'm going to try to fix that, but I'm not counting anything to watch the video except when you go to play pause it and you do those questions, those polls, that should be counted only to the positive. But the way, because the Canvas set and then how you can access play pause it directly from Canvas, I had to make it as assignment, and it had to be graded assignment for you guys to,
Oh.
yeah. But and then somehow it counts negatively or something. So I it shouldn't be that way. I just like what syllabus says. It's nothing. It's not on your grade.
Okay.
So yeah, only counted positive into participation when you do those questionnaire.
Okay.
So I'll try to fix that if I can. Let's see. And today's Zoom invitation, I received a few emails. Have you received it last night, or just
No.
nobody received it last night?
Mm-mm.
No.
I sent to the wrong people.
That's
Oh my
awkward.
gosh. Yeah. Oh, okay. So it's good that you guys, some of you like reminded me, and then okay, I'll just
I was
send it
just gonna
to
click the same link as
uh,
last meeting.
yeah, yeah. So I'm glad thank you so much for some of you being on top. And then uh because of that I made sure to send to everybody. So thanks for that. So that's good that I always try to do the night before. So if you don't receive it by night before, there's something wrong. But I do it like more like in a later night before too. So thank you. All right. So that's weird. I hope we don't have a weird people joining our meeting. Yeah. All right. So yeah, nobody received it. It looks like. Okay. Anybody else have more questions? How was your long weekend? Hot. Hot. It was hot. It was, yeah, that was just too hot. Oh, so I'm glad that you all survived through the heat. Oh my God, you worked. Yeah. So that's right. We can't even like, and then like we can't go anywhere, and it was ridiculous. Uh, we were very very interesting. We are in a very interesting period of our time, and hopefully, but we'll see. We're not going to talk about climate change. It's just I want to avoid that political issue.
That's fair.
Yeah. No, I do have opinion, but I don't want that to be that. So that way. Yeah, which I'm glad. Yeah, if you're from Vegas or something, you might used to this heat, but and it was orange. The sky was orange. Oh, was a dog? Cat?
Sorry.
Okay. Okay, I am going to mute you guys unless you have a question. Okay, good. Thank you. All right, all right. Glad you survived though. Okay, let's see. Today's we're going to start from the atomic sizes, right? Let's share the let's see. Here. So this is the periodic table that we went over. Periodic table is arranged by what number? Sure.
Atomic number.
Atomic number, good. Nice. Yeah, it's atomic number. And atomic number represents the number of what particle in atom?
Protons.
Excellent.
Protons.
Nice, nice. Yeah, it's the number of protons in the atom. So different element, different atom has a different number of protons. And typically atoms comes in a neutral state, electrically neutral state. So the number of protons and number of electrons is the same. But we don't count the number of electrons, and you'll find out why when we talk about ions. It has to be the number of protons for the characterization of an atom. All right. And so we have 118 elements known. But I mentioned the size of an atom varies from about 1 angstrom, 10 to the minus 10 meter to 5 times 10 to the minus 10 meter. It's not too much different, although there are 118 atoms. The sizes don't change so much. And the reason why so is that I mentioned that what is bounding an atom, what force is responsible for making the atomic shape? Do you remember?
The electric force.
Everybody's okay? Yeah, it's the electric force that's responsible. Nice. That's making the atomic structure. There's a stronger force in the nucleus. Perfect. The stronger force in the nucleus that's bounding a proton and neutron. So proton is positively electrically charged particles. And when we go through the electric force, you learn that if it's the like charges, positive and positive and negative, they tend to repel. And unlike charges, plus and minus and plus, they attract. So to be in a nucleus it's with the other protons together, positive and positive, they're going to repel. The electric force is there to repel. However, proton is bounded tightly in a nucleus, so there is a stronger force than electric force that's applied in the nucleus. So there is a stronger force that's not letting the protons leave from the nucleus. But there is an electric force that's attractive force with the plus in the nucleus and the negative electric cloud that's binding the electrons to stay in the inside the atom. So it's the electric force that's responsible for making the entire volume of the atom.
I have a question.
Sure.
Is electric force the same thing as electromagnetic force, or it's different?
Electromagnetic force is talking about two forces together, electric force and magnetic force. Electromagnetism, we're going to talk about it after we go through electricity and then magnetism. Yeah, all these words you're going to find out. But for now, electric forces applies to attractive, becomes attractive force if it's oppositely charged, and negatively charged electrons are attracted to the positively charged nucleus. So because of that, that's what making the shape of the atom. So when you move from hydrogen to helium, the atomic number increases from 1 to 2. That means that you can see it's going to get bigger, right? You have more numbers of protons, you have more number of electrons. You would imagine more particles means bigger atom. But I mentioned that it's the electric force that's binding it. So actually having more number of protons and more number of electrons, the electric force becomes stronger because you have more charges. So it becomes stronger, means more attractive force. So when you move from hydrogen to helium, the size of atom actually shrink because it's a stronger attractive force. So more number of protons and electrons, but size actually shrink. However, when you go from helium to lithium, atomic number 2 to atomic number 3, lithium has how many number of protons?
3.
Very good, 3 protons. And that means lithium has how many number of electrons?
3.
Excellent. 3, right? So, but so it has more numbers. So you think that it may shrink even more. However, the electrons that's making the shape of the atom, there are 3 electrons. So that means that the first 2 electrons can be in the most inner shell, in the first shell. But first shell can only have 1 and 2 electrons stay. The third electron cannot be in the first shell because only 2 seats available for electron in the first shell. So lithium in the second row means the most outer shell is the second shell, and the third electron has to sit by itself in the second shell. So the electrons are now, we have more number of electrons, but the third electron is in the second shell. So that's why it increases in size. So when the atom moves from each shell, each row, 1 to 2, 2 to 3, 3 to 4, the atomic size increases. But then if it moves from left to right, it shrinks. So it's not, the size of the atom doesn't increase or decrease linearly with the atomic number. It goes something like this. Hydrogen to helium shrinks, and then a lithium to neon shrinks. So it goes something like that. Any questions? Yeah.
Why does atomic size matter?
Matter in what way?
I mean, like, why is it important?
Why is it important? We're talking about the atoms, characteristic of atoms. Actually, this is not even a correct picture either. It's not perfectly spherical atoms. This is based on a Bohr model, that's just simplified version. And when you take chemistry class, sometimes you might even see like it has a flower shape, 3D looking, this kind of a shape and stuff. And then molecules we're going to talk about, which shares the composite of atoms, shares, it has more like complicated shape. So it's not quite spherical, and then it doesn't go like this, but you would see that. Why is it important? I never thought about that. It's just so that you see that it's the electric force that's responsible. And then it can make sense by the number, how the atoms are formed, by how many, what kind of particles there. And there is some atoms are heavier than not, and then how about the sizes? Is it go the same way as the atomic mass? Maybe not, right? So the answer is that just because the atomic number increases, it doesn't mean the size of an atom increases. Very good. More question? Okay. Okay, and let me see. So that's the atomic size. Let's go to the another one. Question? All right. Atomic size and then ions and isotopes. So I mentioned that. Let's go back to the periodic table. Let's look at sodium here. Sodium has atomic number, what?
11.
Perfect. Right. Sodium has an atomic number 11. So how many numbers proton you can find in sodium?
11.
Nice. And how many numbers of electrons in sodium?
11.
11 number of protons in 11 number of sodium. Because typically the atom comes in the electrically neutral state. Anybody have a questions finding it? Good, right? Should be straightforward. Okay, so 11 number proton, 11 number of electrons. And so how's these electrons inside the sodium? Is that 2 electrons in the first shell. And another 8 electrons are in a second shell. So that's 10 out of 11 electrons in the first shell and a second shell. But the one last electron cannot be, it's already packed up. So one last electron has to be in a third shell by itself. And the third shell has 1, 2, 3, 4, 5, 6, 7, 8 seats available for electrons to be at. So 1 out of 8 are filled for the sodium in the most outer shell. So this one electron by itself sitting in the most outer shell is lonely, right? It's very unstable. In the cold winter days, when you just rub your hands like this, or you walk weirdly on the ground, you get electric shock when you touch the metal. you get electric shock rather easily, right? So to be having some kind of electric charge is pretty easy. Just a little bit of a friction like this, you can be electrically charged. So removing an electron or adding an electron isn't too hard. The electrons in electron clouds are pretty loose. So this electron that's sitting in the most outer shell that's unstable is pretty easy to remove or to be added. So in the case of sodium that has the only one electron by itself, this one electron in the outer shell tends to be, it's easier to remove this electron. Once you have a electron that's left the atom from the sodium, how do you have more numbers of protons or more numbers of electrons compared to each other?
More protons.
Right. Just because losing an electron, it doesn't mean that proton also goes away from nucleus. The proton stays in the nucleus with a strong force. So proton don't go away, except electron can be just removed or be added. So when you lose or add electrons in the atom, proton still stays the same. So atomic number doesn't change. It's still the same atom, except that atom will be charged, and that's called ions. Ions are still the same atom, it's just electrically charged. And it can be either positive or negative, depends on the type of atom. So in the case of sodium, again, that's in the third row in the most left column. So in this case, the word which column it's at matters. So the sodium is in the most left column. And that means that one electron is sitting by itself in the most outer shell. So one electron is sitting, and then all the other 10s are nicely packed. But because there's only one electron in the most outer shell, sodium tends to lose one electron. If the sodium loses one electron, does it going to be a positive ion or negative ion?
Positive.
Positive.
Everybody okay, right? It's going to be a positive ion by 1. So we write Na plus for the sodium ion. Let's look at magnesium that's in next to the sodium. What's the atomic number of magnesium?
12.
12.
Very good. 12 protons, and therefore typically magnesium has how many number of electrons?
12.
Good. 12, right? And 12 protons, 12 electrons. But again, similar to sodium, the 2 electrons stay in the first shell, 8 electrons stay in the second shell, but left over 2 electrons now in the most outer shell, in the third shell. But the third shell has, again, availability of 8 position for electrons, 8 electrons, but only 2 are filled. So comparing to adding the 6 electrons in the most outer shell or removing the 2 electrons, which will be easier, to remove 2 electrons or add 6 electrons?
To
Remove
remove.
2.
It's easier to remove 2 electrons than adding 6 electrons, right, in the most outer shell to be stable. So therefore, magnesium tends to lose 2 electrons and becomes either positive or negative ion.
Positive.
That's right, positive ions by 2. So in the case of magnesium, rewrite Mg 2 plus. because it loses 2 electrons. So you can see that I mentioned the column is more important talking about ions. Most left column here in the periodic table tends to lose electrons, 1 electron. Because all this left column, most left column, have 1 electron sitting in the most outer shell. And then the second from the left column here tends to, they only have a 2 electron in the most outer shell. So it's easier for them to lose 2 electrons. So they tend to be +2. Interesting thing is the column that's most right column here. Noble gas, inert gas. This column is called noble gas or inert gas, right? They have they're in the most right column. That means that all the electrons are nicely packed in the outer shell. So all the electron shells in all this noble gas have electrons that's filling the most outer shell. Therefore, they're very, very stable. It's not so easy to remove or add electrons. That means that they don't become ionized. So these helium, neon, argon, krypton, xenon, and radon, they don't become ionized. They're very stable. They don't even form a chemical bond. Chemical bond means usually sharing electrons. But helium, neon, argon, krypton, and xenon, radon, they're nicely stable by itself. So they don't need to share, borrow, or give electrons. So they're very stable and chemically inactive. On the other hand, the second column from the right, let's look at the chlorine, right? Here. Chlorine has atomic number what?
17.
Nice. Atomic number 17. So for chlorine, we have 2 electrons in the first shell and 8 electrons in the second shell and 7 electrons in the third shell. So there is one available spot of electrons for chlorine. So in the case of chloride, is it going to be positive ion or negative ion?
Negative.
In the case of chloride, because it has only one spot available, very good, it's hard to remove all the 7 out of 8 available spots. But to introduce 1 into that one available spot is so much easier. So chlorine tends to have a borrow the 1 electrons from somewhere to make it stable. So now chlorine ion would have excess electrons compared to protons, number of protons. So they tend to form negative ion by 1. So the second most right column, all these elements, they tend to be ionized positively or negatively.
Negatively.
Very good. All this second most right column tend to be ionized negatively by how many?
1.
1.
Very good. 1, right? Oops. Yeah, I think I need to change the setting. You guys can somehow access to the thing. So this most right column tends to be -1, and therefore this one, the third column from the right, will be positively charged or negatively charged ion.
Negatively charged.
That's right. Still negatively charged, and by how much?
2.
2. Anybody have a questions? Okay. How do we get to the polls? Let's see, no. Sorry, I need to take out the. So here is a poll that I want you to do. Let me know if you have a technical issue accessing to the poll. You might not be able to see the period. If you're attending a lecture from your phone, it may be hard for you to take the poll. So I believe this is all about nitrogen. Can you see the poll?
Yeah.
Good, 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 good. So this is, I believe it's all about nitrogen. Yes. Nitrogen has atomic number 7, and it's located on the second row and the 1, 2, 3, fourth column from the right. So second row, fourth column from the right. Atomic number 7. Very good. Good, good. Good. So give you a little more time. Let me know if you have a technical issue submitting a poll. All right. I'm gonna wait until 3 minutes. And I assume that if whoever is not doing it is having a technical issue or something. Okay, so I assume everybody attempted. Let's see. Let's see. So the atomic number of nitrogen is 7, as I mentioned, and that's good. How many numbers of protons in the atom? Should be 7 protons, right? Good. How many number of electrons in nitrogen? Should be 7, still the same. And how many electron shells? So this is about the electron shells. So you have a 7 electrons, so there are 2 shells. The 2 electrons sits in the first shell, and how many? 7. So 5 electrons sits in the, thank you, yeah. 5 electrons sits in the second shell. So there are 2 shells that's filled. So that's what it means. Any questions for this? Okay, question? No. All right, so that's I have another question about nitrogen, but I think I talked about isotopes too. So let's finish up isotopes. So that's how it is with the ions. Do you have anybody have a questions about ions? How to so the excess electrons compared to protons is positive or negative ion?
Excess electrons to protons is
Yeah.
negative.
Very good. Negative, right? So then the deficiency of electrons is positive or negative?
Positive.
Positive.
Very good. Very good. Positive. And it is, make sure that it is the electrons that's either losing a number or gaining a number. It is not the proton, right? So that's why you can see the atomic number is organized by the number of protons. Number of protons stays the same. Electron can be freely leave or join, but it won't change the characteristic of atom. You still, with your sodium, you're still sodium. It's ionized sodium or sodium is still sodium because atomic number does not change. All right? And then you should be able to find out by how many it becomes ion. Positive 1, positive 2, positive 3, negative 1, negative 2, negative 3. Anybody's not sure how to do that still? Or question? Good. Another one, isotopes. So ion is the electrically charged state of an atom. Isotopes, when you hear isotopes, people tend to think that all the isotopes is radioactive. It's not the case. The definition of isotopes is just that you have a different number of neutrons this time. So some atoms naturally or man-madely have a different number of neutrons. So let's see here. We have a picture of a hydrogen atom. The most left one is the most common one that has a 1 proton and 1 electron, hydrogen. But some hydrogen actually has 1 proton and 1 neutron and 1 electron. You still have a same number of protons, so it's still hydrogen. And also you have the same number of electrons, so it's a hydrogen atom that's neutral, not ionized. You just have 1 extra neutron. And having the extra neutron or having the less number of neutron means that it doesn't change its electrical state because neutron doesn't have any electrical charge. So what it does is just make the atom either heavier or less heavier. Remember that an electron weighs only 1/2000 of protons or neutrons. Proton and neutrons are a lot heavier than electron by 2,000 times. So if you become ionized to lose electrons or gain electrons doesn't really change the atomic mass. Atomic mass is only contributed by the number of protons and number of neutrons. So we call this a hydrogen atom that has extra neutrons called heavy. Sometimes we just say heavy hydrogen. It's exactly the same hydrogen because again, the atomic number doesn't change. Number of proton doesn't change. But because you have more neutrons, it just makes the atom heavier. Does it change the shape of the atom?
No.
Does the isotope, you think that's going to change the shape of the atom?
No.
yeah, shouldn't really matter, right? Because it doesn't have any electric charge, so it just makes it heavier. And I mentioned that isotopes are not always radially active because you do see in nature, some hydrogen just comes heavy. I believe it was about 0.017, 0.0017% of hydrogen is isotopes. Let me make sure. 0.015%, 0.015% of hydrogen is isotope. It can be a heavy hydrogen. It sounds very small, but I mentioned that in a gram of water, you have a 10 to the 23 atoms that has a hydrogen, right? H2O. 10 to the 23 atoms. So that means that when you drink water, there are quite a bit of atoms. The hydrogen is heavier hydrogen. So when you have a 10,000, that means that when you have a 10,000 atoms, among the 10,000 atoms, 15 atoms are heavier hydrogen. So when you have a 10,000 hydrogen atoms, 15 of them is heavier hydrogen. So when you have a gram of water that has 10 to the 23 atoms, that means that quite a bit of the atoms are heavier. And we drink water without worrying about radioactive decay, right? So some isotopes are very stable and it's safe. However, there are some isotopes that's unstable and they tend to radioactively decay, then it's not safe for us. So of course, those heavy atoms that are made in a lab and things, that's unstable, and when they decay, then it's not safe. So let's see, let's look at the periodic table again. Entropy. Entropy is something that is a measurement of a disorder. So it's not related to the decaying process. It's more like a thermodynamics, state of a disorder. Thank you. So here's the periodic table again. Let me see. Let's look at the hydrogen here. So there's a hydrogen here. We say this number represents what? What's this number represent?
Atomic number.
The number above H represents the atomic number. Very good. Thank you. Number of protons. Right. Atomic number, and it's the number of protons. And then we have a symbol for the element, and then it has the name of the element or atom, hydrogen. And then here, 1.0079, this is the atomic mass, 1.0079. Again, the atomic mass is contributed by the number of protons and number of neutrons, right? Number of electrons doesn't really contribute to the mass for the atomic mass because electron is so much lighter. Having the extra number of protons or not makes a bigger difference, and so as the neutrons. But when you count things, number of protons and number of electrons, can you have 2.3 dogs?
Nope.
It's quantized, right? Number of dogs is quantized. You can't have a 2.3 dogs. Same as the number of protons and number of neutrons. So hydrogen typically has a 1 proton and 1 electron, atomic number 1. So most of the hydrogen has an atomic mass 1, because 1 proton. But I mentioned that some of the hydrogen have a heavier hydrogen that has a 1 neutron, 1 proton, 1 neutron, or even 1 proton and 2 neutrons. So those are heavier, that has atomic mass to be either 2 or 3 mass, same atomic number. So this atomic mass in the periodic table is the average of all the atomic mass. So it says 1.0079. That means that most of the hydrogen has atomic mass 1, but some of them are heavier by this much portion. So let's see, helium. Helium's atomic number is
2.
2. How many number of protons in helium?
2.
2.
2.
How many number of electrons in helium?
2.
Good. How many number of neutrons do you think that typical helium would have?
2, right?
2.
Does anybody want to explain how you found that helium has 2 neutrons?
For the atomic mass, which is 4. So you just minus atomic number, which is 2. That's equal to neutron.
Right, very good, very good. So we look at this periodic table here. It says 4.003. We round off to the closer integer because the non-quantized number is due to the isotopes, right? So most of the helium has atomic mass 4. The atomic mass 4 means that there are 4 nucleons. It's either protons or neutrons. We know that helium has atomic number 2. We know that helium has atomic number 2. So there are 2 protons. So 4 nucleons means that 2 out of 4 is the proton, and then the leftover 2 is the neutrons. So you round off this number to the closest integer, the atomic mass, in a periodic table, then minus the atomic number will be the number of neutrons. Let's do argon. What's the atomic number for argon?
18.
18.
Good, 18. And then how many number of electrons in argon?
18.
Good. How many number of neutrons in argon?
22.
You guys are awake in the morning. Very good. Subtraction. Fast. So most of the argon has atomic mass 40, 39.948. So it's 40. Then you minus the atomic number, 40 minus 18, 22. So 22, it tends to have a 22 neutrons. Some of them can have a 38 neutrons. Sounds good? Okay. Let's see. Where does it go? Disappears. Then I have another pause. Oh, yeah. Here. Ah, this is how I do. Okay. So here's another poll. Again, nitrogen atom. How many neutrons in nitrogen atom? Nitrogen again has atomic number 7. Locates second row, fourth column from the right. And atomic in a periodic table it says 14.007. Atomic number 7, and then it says 14.007. Oh no. Yeah, I don't know. I'm still figuring out about all the polls and stuff, but
I
hopefully
think
you.
maybe
Hmm?
you might be able to see it on the bottom row where it says participants and chat.
Oh yeah, good, good, good.
Maybe.
Try that. Yeah, thank you. Try that. I hope you submitted. I'll wait for 10 more seconds. Everybody good? I'll make sure everybody who wants to participate can. Okay, so yes, everybody voted on 7, right? Any questions on that? Very good, very good. How fun. Okay, good. Isotopes, talked about that. Compounds in the mixture. Let me see, I have another question made, right? Here. Oh yeah, this is about iron here. This is another question. It's again about nitrogen. Nitrogen that has atomic number 7 that's located in the 4th column from the right. 4th column from the right, most right. And it's in the 2nd row. Can everybody see the poll, huh? Right? So I give you a few minutes. Okay. Looks like most of the people voted. Let's wait just a little bit more to make sure. Thank you. All right, so let's see. I'm going to close the poll and let's look at the answer. So nitrogen is has an atomic number 7, and it locates on 1, 2, 3, 4th column from the right in the second row. So that means that what is it? 1, 2, 3, 4, 5 electrons are sitting in the most outer shell. 5 electrons are sitting in the most outer shell. That leaves 3 seats available, 3 open seats. So it's easier to add 3 electrons than to remove all 5 in the most outer shell. Any questions? To add 3, that means that it's going to be more number of electrons than the protons. So it's going to be negative ion. Then by how much will be 3? Adding 3 electrons. So that's what it is with the 4th column from the most right, because the inner gas, noble gas, not going to be ionized. They're nicely packed. But the second column from the right becomes -1 ion. And then the third column from the right, like oxygen and sulfur, they become -2 because they have 2 open seats. So nitrogen, phosphorus, they have 3 open seats. It is the carbon, silicon. These carbon and silicon, right? They have a carbon, let's say, atomic number 6. So 4 electrons are sitting in the most outer shell, in the second shell. That has the 1, 2, 3, 4 electrons. But carbon also has 4 open seats. So 4 electrons and 4 open seats. That means that carbon doesn't really become ion. It can be positive sometimes, but it won't be ion as easily. It's just they don't need to add or lose. However, though, because to become a chemically compound, to be chemically becomes more than one atom chemically, then I mentioned that I think I mentioned that they tend to share electrons. So let's look at sodium and a chloride, right? The sodium has the 1 electron sitting by itself in the most outer shell, on the 3rd shell. On the other hand, chlorine has 1 open seat available, right? So chlorine tends to be negative, sodium tends to be positive. +1 and -1. Oops. Everybody okay with that? So, but at the same time, because chlorine has a 1 open seat and the sodium has a 1 extra electrons, so they tend to share that spot and form sodium chloride, salt, NaCl. Chlorine happens to have a 1 open seat, sodium happens to have a 1 extra seat, extra electrons, and they share that. So when the atom becomes the compound or the molecules, they share the electrons. In the case of carbon, it's not that carbon has a hard time becoming ionized because it has the same number, it's just even number. You have a whatever that electrons that's filling and whatever that's open seats, that's same number. So it's kind of stable. It's hard to be ionized, but it doesn't mean that they're chemically inactive. You hear ammonia, that's CH4, right? So the carbon has a 4 open seats that shares with the 4 hydrogen atom. Right. So it doesn't mean they're chemically inactive like this noble gas. This noble gas is not going to be ionized, and they're also not going to be chemically reactive. Carbon or silicon can be chemically active, but they're just not going to be ionized as easily. So that's a little different story. The noble gas is most stable, chemically stable, and then it's not going to be ionized. No, natural state of carbon is just neutral. So they tend to be electrically neutral. It's hard to find a C+. They're not going to be ionized as easily by itself. But you do find like a CH3+. After you form a chemical compound with the other atom, then it can be ionized. Like a missing, yeah.
So, okay, so carbon has 6 protons and 4 electrons on the periodic table?
No, I'm sorry. Good. Carbon has a 6 protons and 6 electrons, but 2 are sitting in the first shells, left over 4 in the most outer shell.
Oh, thank you. Okay.
Yeah, so when we talk about ions and things, we're looking at the most outer shell. Those inner shells that's already been filled are already stable, so we were interested in the most outer shell. Thank you for confirming. So I was talking about 4 electrons in the most outer shells, 2 other electrons are in the inner shell, the first shell. That's nicely packing. So in the outer shell, the carbon has the 4 electrons, but then the shell has a 4 available seats. So electrically neutral, and then they do become chemically active. It's just that it's hard to be ionized. But nitrogen that we did on the pole, it has a 3 open seats and then filling up of 5 electrons. So nitrogen tends to be positive 3. All right. Any questions so far? Oof, I shouldn't be. From the next class, I really gotta just do the questions. I can't be talking too much about that thing because you guys are already watching the lectures. I'm really using up class time. So atomic number, can you see atomic number of an element matches the number of, easy?
Yes.
Yes.
C.
But atomic number, so When it says atomic number, strictly,
Oh, A.
yeah, I want you to be, yeah, sticking with the definition. Thank you. Anybody have a, oh, shoot. Yeah. Sorry about that. But I would, I would, I would do A. But if it's an exam, I'm gonna give both A and C correct. Because I'm not clear with the question. So I gotta try and avoid that kind of a question. One more. Oh, can I go to the next slide?
Yep.
All right. Nucleus over there, atomic number 44 and the mass number 100 must have good. In this case, no ambiguity. Good, good, good. Right? There's no ambiguity. It's 56 neutrons. Very good. Questions?
Sorry, just to clarify. So, sorry. So a mass number is the protons plus the neutrons, correct?
That's right. Nucleons, number of nucleons. Yes.
Just making sure. Thank you.
Yeah, yeah. Thank you. All right. And compounds and mixtures. Let's just finish it here. So I mentioned that you can chemically form, atoms can be formed to become another substance. And that's called molecules. Sorry, I'm just gonna go next one first. Molecules are bonded, chemically bonded together. So when you have a multiple atoms, chemically bounded together, that becomes molecules. So when you have a 2 oxygen, and that becomes O2, that's molecules. The molecules can be compounded with the same kind of atoms or different kinds of atoms. Like NH3 has 1 nitrogen and 3 hydrogen. So it could be formed with different types of atoms, or it can be formed with the same kind of atoms. Is that good? So there is new substance, new chemical substance that has more than 2 or more atoms bonded together. That's called molecules. Molecules can be ionized too, by the way. So those are molecules. Compounds is the new chemical substance that's chemically bounded. But in the case of compound, it's formed with 2 or more than molecules. That's different molecules. So like O2 is not compound. It's just a molecule. But NH3, ammonia, is a compound. And mixture, when we say mixture, that's a substance that has the different kind of chemical substance mixed in together. Like for example, coffee, I'm drinking a coffee that has the milk and coffee, right? And I call it latte. It's not espresso beans, but right, latte has a coffee and a milk. So that's a mixture because coffee is one kind and the milk is another kind that's mixed in together. When we say water, it can be confusing, so I need to be very clear with the water. When you talk about tap water has not just H2O in it. they have metals that's melting and other kinds of things for. So tap water is a mixture. But when I say water molecule, H2O, that becomes, what is it, compound or mixture?
Compound.
Right? Water molecule is a compound, not a mixture. Very good, very good. So that's the difference between a compound and a mixture. Mixture is not really a chemically bounded substance. It's the mixture of a different kind of substance. And compound is made of more than 2 molecules. That's a different element. And molecules are chemically bounded, more than the 2 atoms are chemically bounded. It can be the same kind or it can be different kinds. All right. Okay. Chemical reaction is typically a reaction that shares the electrons. And you need energy to form a new chemical substance. So when you pull the molecules apart, it requires the energy. And then when you combine the atoms together, it releases some energy. You have an extra energy to make it stable, so it releases some energy. That's extra energy. So that's that chemical reaction. Questions? Yeah, I'll talk about this in the next class. So let's see. Yeah, you guys doing way too much. I'm gonna end today's discussion here, but I feel like we're doing way too much. Gotta find a way to make the lecture a lot shorter. I tend to talk about the concept, but I'm gonna assume you guys watching the video nicely. It seems like you are. So I gotta we might just do only the questions and skip the concept unless you have a questions. You know? I hope I can do this. I'm not good at it. I tend to talk. So, but anyhow, we're going to pick up the antimatter next class, and then we're going to do chapter 2 on the next week, Monday. So I'm going to upload a new videos for next week, Monday. And there's an atom worksheet that I uploaded in chapter 11 folder. We might not have time to do that in a class. I wanted to do it in a class. I should have just done that today, and then but I don't have time, maybe. So if you can work on it and then come up with a question, it would be nice. There's one question that I made that I erased it, but that's because I thought we might not be able to get into mixture, but we did it. So you can do all 10 questions. All right. So if you want to, you can work on that and ask me a question. All right. What's this text message? I don't understand. But yeah, unless you have questions, I'm going to communicate, and then don't worry about the negative points in Play Pause It lectures. From now on, you're going to access directly from Canvas website to Play Pause It, and I'll try to fix on whatever the incomplete that giving you a 0. All right. So see you on next Monday. And I'll
see you Monday. Have a good weekend.
Thank you.
See you Monday, Professor. Thank you so
Yeah.
much.
Thank you.
Have a
Bye.
wonderful weekend.
See you,
Oh,
Professor.
Professor.
Buggers.
Yeah, if you have a question, stay here. I'll close the video. Thank you. See you guys.